I want to show you that the oscillation frequency of a pendulum doesn't at all depend on the mass. To do this, I'm going to use the heaviest thing that I can think of as the mass on a pendulum. I have a rope here and myself as the heaviest thing. And therefore, I'm going to put myself into oscillation in this Pupaendulum. So I'm going to start oscillating and count 5 oscillations. Start. Every time I go back to the opposite side, 1, 2, 3. I count every time I get to the opposite swing. 4. And stop the timer just about now. So 23.6. Let's round it up to 24 seconds. Let's now try precisely the same timing for 5 oscillations, starting from precisely the same position as before, which is exactly here, and letting this go until it does 5 oscillations and counting the time. With what mass? No mass. Just this small piece of wood on which I was sitting before, but basically very different mass compared to heavy pupa. So let's get started. Let go of this. 1, actually start. 1, 2, and this is going to be very similar. 3 to the previous one. Not much of a difference. 4. And 5, 22 seconds. So within the 1 or 1.5 second error of this entire measurement, these two frequencies are similar to each other. Let's take the average, 23 seconds. So the previous one was 24, this one is 22. The average would be 23. So if I calculate how long one of these 5 oscillations takes is 4.6 seconds, and the frequency, therefore, is 0.2 hertz. The frequency of oscillation with heavy Pupaendulum and empty Pupaendulum are exactly identical to each other, or within the error, identical to each other. Thank you.